Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Now, today in this first video lecture of week 15th for the course Differential Equations, we are going to learn about the solution of first order nonlinear differential equations. For the solution of non-linear differential equations, dear students, note that sometimes equations solvable for p and y, and sometimes equation solvable for x. So first of all, I would like to tell you that when equations solvable for p, then how to solve the non-linear first order differential equations, and when equation solvable for y, then how we can solve the non-linear first order differential equations, and similarly when equation is solvable for x. So in this video lecture I would like to tell you about the solution of non-linear first order differential equations. So sometime equation will be solvable for p, sometime equation solvable for y, and sometime equation solvable for x, where this p is actually equal to dy by dx. So first of all, I would like to tell you that when equations is solvable for p, for example, you see over here x square p square plus xyp minus 6y square is equal to 0. This is a non-linear first order differential equations, and this differential equation p is equal to dy by dx. So when the equation is solvable for p, then factorize this differential equation. First of all, factorize this differential equation. When we replace dy by dx by p, then it's seen like algebraic equations. So this is now seems like an algebraic equations. So for the algebraic equation, first of all, factorize this algebraic equation. By factorization, we know that x square p square plus xyp minus 6y square is equal to 0 actually equal to, now factorization by sum and product, x square into p square plus 3xyp minus 2xyp minus 6y square is equal to 0. Now taking common xp from these two terms, xp into xp plus 3y, and taking common minus 2y from these last two terms, so minus 2y into xp plus 3y is equal to 0. Now again taking common xp plus 3y, so taking common xp plus 3y, we have xp minus 2y into xp plus 3y is equal to 0. Now we consider that the product of these two factors is actually equal to 0, mean that maybe both factors are equal to 0 or one of them are equal to 0. So suppose if xp minus 2y is equal to 0, then xp is equal to 2y, and xp mean p mean dy by dx, so replace p by dy by dx. Now this is a first order differential equation. X into dy by dx is equal to 2y. Now we can easily solve this first order differential equation by separation of variable. So for the separation of variable, now we have x into dy is equal to 2y dx. So this can be written as 1 over y into dy is equal to 2 by x into dx. So in this tip you see over here, separation of variable is possible. Now taking integration, we have integration of 1 over y with respect to y is equal to 2, and to integration of 1 over x with respect to x, and the integration of 1 over y with respect to y is equal to log of y, and the integration of 1 over x with respect to x is equal to natural log of x plus c, this is the plus log of c, this is the constant of integration. Now we can write log y is equal to log x square plus log c, and now log y is equal to log into cx square, and this implies that y is equal to cx square. So this is the solution of the first or for the first order for this first factor, and this factor you see over here, this is the first order differential equation. So now again, to solve this second factor, xp plus 3y is equal to 0. So xp plus 3y is equal to 0 mean uh, xp is equal to minus 3y, and now p replaced by dy by dx. So x into dy by dx is equal to minus 3y. Now for the separation of variable, now this is again the first order differential equation, so we can solve it by separation of variable. By separation of variable we can write x into dy is equal to minus 3y into dx, and now this can be written as 1 over y dy is equal to minus 3 by x into dx. Now separation of variable is possible. Now taking integration of 1 over y with respect to y minus 3 into integration of 1 over x with respect to x, and so the integration of 1 over y with respect to y is equal to log of y is equal to minus 3 into log of x. Integration of 1 over x with respect to x is actually equal to log of x plus log of c. Log of c is the constant of integration. Now this solution can be written as log y is equal to minus log x cube plus log c, and this implies that log y is equal to log of c by x cube. So this is the solution of the second factor. Now dear students, you see over here, when we factorize the given non-linear differential equation, we have two factors. When equation is solvable for p, then we can factorize for this purpose to that equation is, when equation is solvable for p, then factorize the equation, we obtain two factors. Each factor will be the first order linear differential equation. So solve each factor. So when we obtain two factors, then there will be two solutions. So one solution is for the first factor and other solution is for the second factor, and the overall solution of the given differential equation will be multiplied both solutions of these two factors, like you see over here. So the solution of the given differential equation will be equal to y minus c by x cube and to y minus c x square is equal to 0. This is actually the solution of the first factor, and this is the solution of the second factor. So dear students, note that actually the given equation is the first order non-linear differential equation. P mean dy by dx, dy by dx whole square. Because of this whole square, and because of degree of dependent variable y is more than 1, so this is the non-linear differential equation, but first order non-linear differential equation. So actually the first non-linear differential equation is factorized when equation is solvable for p. So factorize the equation, we will obtain the first order differential equations. And the first order differential equation can be easily when there are two factors, each factor will be the first order differential equation. So solve each factor, and then when we obtain two factors, there will be two solutions for each factor. There will be one solution for the first factor and other solution for the second factor. So multiply the solution of these factors, we will obtain overall solution of the given differential equations, like you see over here. Multiplied these two solutions, this is actually the solution of the first factor and this is the solution of the second factor, and after multiplication of these two solutions we obtain the solution of the given differential equations. Now similarly another problem, x into p square plus y minus 1 minus x square into p minus x into y minus 1 is equal to 0. So when equation is solvable for p, we can factorize it. Xp square plus y minus 1 minus x square into p minus x into y minus 1 is equal to 0. Now rearrange the term, xp square minus x square p plus y minus 1 into p minus x into y minus 1 is equal to 0. Now for the factorization, you see over here, xp into p minus x plus y minus 1 into p minus x. From these two terms we can take common xp. In these two terms xp is common, so xp into p minus x plus y minus 1 into p minus x is equal to 0. Now p minus x is again common, so p minus x into xp plus y minus 1 is equal to 0. So we have two factors. So first factor, p minus x is equal to 0, implies that p is equal to x, and p mean dy by dx. So for the separation of variable, we can write dy is equal to x into dx. Now taking integration of 1 with respect to y and integration of x with respect to x, which implies that y is equal to x square by 2 plus c. And this solution can be written as y minus x square by 2 minus c is equal to 0. Now this is the solution of this first order differential equation. Now solution of the second factor. In the second factor, we again obtain first order differential equations. So xp plus y minus 1 is equal to 0 mean x into dy by dx plus y is equal to 1. And dear students, now note that this factor is actually a linear, first order linear differential equations. Dear students, when we factorize the non-linear differential equation, it is not necessary that equation reducible to linear form. Sometime maybe we obtain a factor in a linear form, because you see over here in this in these two factors, this is actually the linear differential equation. This is the first order linear differential equation. This is the first order differential equation. This is not a linear. And in this equation you see over here, this is the first order differential equation but linear. So it is not necessary that the nonlinear differential equation will be converted to the linear differential equation after factorization. This is not necessary. Maybe sometime we get a linear differential equation factor. So this factor, there are two factors. This factor is actually a linear factor. Now we can solve this linear differential equation as you see over here, dividing both sides by x, dy by dx plus 1 over x into y is equal to 1 over x. Now this is a linear differential equation in variable y and dependent variable y. For the solution of linear differential equation, we need an integral factor. So integral factor is equal to e power integration of p of x with respect to x. The coefficient of y is a function of p. So now we obtain actually this is the general form of linear differential equation, dy by dx plus p of x into y is equal to q of x. First order linear differential equation, general form. This is the general form of first order linear differential equation. So when we compare this general form to this equation, here p function is actually equal to 1 over x and q function is also equal to 1 over x. So the integral factor is equal to e power integration of 1 over x with respect to x. Integration of 1 over x with respect to x is equal to log of x. So e power log of x is equal to x. So this is the integral factor. Now the solution of the first order linear differential equation is given by this formula. Integral factor multiplied with the dependent variable is equal to integration of product of integral factor multiplied q function with respect to x plus constant of integration. So x is the integral factor multiplied with dependent variable y is equal to integration of integral factor multiplied 1 over x. 1 over x is actually the q function. So x and x cancel. Now we obtain xy is equal to integration of 1 with respect to x plus c, and the integration of 1 with respect to x is equal to x. So xy is equal to x plus c, and this solution can be written as xy minus x minus c is equal to 0. Now this is equation number 2. In equation number 1, we obtained the solution of the first factor. This is the solution of the first factor. And equation number 2, we obtained solution of the second factor. Now multiplied these two solutions, we obtain the overall solution of the given non-linear first order differential equations, which is equal to y minus x square by 2 minus c and to xy minus x minus c is equal to 0. Now another problem, p square minus 7p plus 12 is equal to 0. This equation is easily solvable for p. So when equation is solvable for p, multiplied factorize the equation, we obtain p square minus p minus 4p minus 3p plus 12 is equal to 0. By sum and product, we can write p square minus 4p minus 7p p square minus 4p minus 3p plus 12 is equal to 0. Now taking common p from these two terms, we obtain p into p minus 4. In taking common minus 3 from the last two terms, we obtain minus 3 into p minus 4 is equal to 0. Now p minus 4 is again common, so we can write p minus 3 into p minus 4 is equal to 0. So there are two factors. Now p minus 3 is equal to 0 mean p is equal to 3, and p mean dy by dx. So dy by dx is equal to 3. So dy by dx is equal to 3 mean dy by dx is equal to 3. This implies that dy is equal to 3 into dx. So by separation of variable, now separation of variable is possible. So taking integration of 1 with respect to y and integration of 1 with respect to x. So we obtain y is equal to 3x plus c. And this solution can be written as y minus 3x minus c is equal to 0. So this is the solution of the first factor. Now the second factor is p minus 4 is equal to 0. P minus 4 mean p is equal to 4 and p is equal to dy by dx. So dy by dx is equal to 4. Now this implies that dy is equal to 4 dx. Now separation of variable is possible. So taking integration of 1 with respect to y and integration of 1 with respect to x. So this implies that y is equal to 4x plus c, and this solution can be written as y is equal to minus 4x minus c is equal to 0. Now equation number 1 represent the solution of the first factor, and equation number 2 represent the solution of the second factor. Now multiplying these two solutions, we obtain the solution of the given differential equation y minus 3x minus c into y minus 4x minus c is equal to 0. Now when equation is soluble for y, first order non-linear differential equation is soluble for y. Dear student, actually in the first non-linear differential equation we have three variables, suppose x, y and p. So like algebra, when equation involve two variables, suppose x and y, so sometimes we solve the equation for x and sometimes we equation solve for y. So when equation is solved for p, when equation is easily solved for p, we can solve equation solved for p, and sometimes equation will be easily solved for y, sometimes equation is easily solvable for x. So when equation is solvable for y, then first of all write the equation, express the equation in the form of y will be expressed in term of x and p. When equation is solvable for y, so express the equation y will be expressed in term of x and p, like you see over here 2y, shift this term minus 2x square into y to the right hand side and then dividing both side by x square, we obtain 2y is equal to xp plus p square by x square. And when the equation express y express in term of x and p, then in the second step differentiate the equation with respect to x and replace dy by dx by p. So 2 into dy by dx, differentiate the equation with respect to x, we obtain dy by dx is equal to, here we can differentiate this product by using product rule. So first function is derivative of the second function, p derivative with respect to x plus p into derivative of the first function into derivative of second function plus second function into derivative of first function, and here we can use the quotient rule. So x square is a first function, x square into derivative of second function is p square, minus p square into derivative of first function divided by square of the denominator. Now we obtain dy by dx is actually equal to p, so 2p is equal to x into dp by dx plus p, derivative of x with respect to x is 1, and plus 2p by using the chain rule, 2p into x square, and again derivative of the base dp by dx minus p square, and derivative of x square with respect to x is equal to 2x divided by x power 4. Now we can write 2p is equal to x into dp by dx plus p plus 2p by x square into dy by dx minus 2p square divided by x cube. Dividing each term in this fraction by x power 4, we obtain 2p divided by x square into dy by dx minus 2p square divided by x cube. Now 2p minus p plus 2p square divided by x square minus x into dp by dx minus 2p by x square into dy by dx is equal to 0. So this equation now can be written as p plus 2p square divided by x square minus xp dp by dx minus 2p by x square into dy by dx is equal to 0. So subtract p from this 2p, we obtain p. Now from these two terms taking common p into 1 plus 2p by x square, and from these two terms taking common minus x into dp by dx, so minus x into dp by dx into 1 plus 2p divided by x square is equal to 0. Now 1 plus 2p by x square is again common, so we can write p into minus x into dp by dx into 1 plus 2p by x square is equal to 0. Now 1 plus 2p by x square is equal to 0, neglect this term, and we can consider p minus x into dp by dx is equal to 0. Now we can write p is equal to x into dp by dx, and this equation can be written as actually in this equation we obtain p and x. So equation is by separation of variable, we can write p into dx is equal to x into dp, and this implies that 1 over p dp is equal to 1 over x dx. Now taking integration, we obtain integration of 1 over p with respect to p and integration of 1 over x with respect to x. So we can write integration of 1 over p with respect to p is equal to natural log of p is equal to integration of 1 over x with respect to x is natural log of x plus log of c is the constant of integration, and this implies that natural log of p is equal to natural log of c into x. So this implies that p is equal to cx. Now put in this equation 2y is equal to xp plus p square by x square for the elimination of p. Actually this p is actually dy by dx. So when we replace dy by dx by cx, the equation will be easily solved, and this solution is now equal to 2y is equal to x into cx plus c square into x square divided by x square. So we can write 2y is equal to cx square plus c square, and this is the solution of the given differential equation. Dear students, note that when equation is solvable for p, we have p in the left hand side. Suppose we have p in the left hand side and p is actually dy by dx, we have to solve dy by dx, the differential term for y, because y is a dependent variable. Now since in this second case equation is solvable for y, when we express y in term of x and p, equation is solved for y, but in this solution actually p is presented. So to eliminate this p, we can obtain the solution, because p is not a simple p parameter. P is actually equal to dy by dx. This is the differential operator. So when we replace the differential operator by some term, we will obtain the solution of the given differential equation. So since in this solution you see over here p is equal to cx, so when we replace p by cx, we will obtain the solution. So when we solve equation for y, the equation will be solved, but in the solution p will be present. So to eliminate p, we will obtain the solution. Now another example, y minus 3xp is equal to p square. So this equation can be easily solved for y. We can write y is equal to 3xp plus p square, but in this solution actually p is present and p is actually equal to dy by dx. So when we eliminate this p, we will obtain the solution. Now how to eliminate this p? For this purpose, we differentiate the equation with respect to x. So dy by dx is equal to, now by product rule, x into dp by dx plus 3p into dx by dx plus derivative of p square with respect to x. So here we can use the chain rule. So we obtain p is equal to 3x into dp by dx plus 3p plus 2p, and again derivative of the base. 2p into dp by dx is actually the derivative of p square with respect to x. Now p is equal to 3p plus taking common dp by dx from these two terms. So dp by dx into 3x plus 2p. Now we can write p minus 3p is equal to 3x plus 2p into dp by dx. So we obtain minus 2p is equal to 3x plus 2p into dp by dx, and now we can write minus 2p into dx by dp is equal to 3x plus 2p, and this p now we can write dx by dp is equal to minus 3 and divided by 2p into x minus 1, and this implies that dx by dp plus 3 divided by 2p into x minus 1. Now this is a linear differential equation and dependent variable x. So for this purpose we need an integral factor. Now this is the dependent variable, x is the dependent variable, so the coefficient is actually the p function in the general form of linear differential equation. So 3 divided by 2p, integral factor will be equal to e power minus 3 by 2 into integration of 1 over p with respect to p. So we have, so the integral factor will be equal to e power 3 by 2 integration of 1 over p with respect to p. Now integral factor is equal to e power 3 by 2 natural log of p, and this is equal to p power 3 by 2. So the solution is a dependent variable multiplied integral factor is equal to integration of integral factor multiplied q function. Minus 1 is actually the q function. So this implies that x multiplied p power 3 by 2 is equal to minus p power 3 by 2 plus 1 divided by 3 by 2 plus 1 plus constant of integration. So this is the solution. Now since this in this solution it is not easy to eliminate p, so this is the solution, the required solution. Now p will be treated as a parameter. So dear student, in this video lecture you see over here, when equation is solvable for p, then first of all factorize the equation. We will obtain the factors and solve each factor. When we factorize, after factorization we obtain the first order differential equations. So solve each first order differential equation and then multiply the solution of each factor, we will obtain overall solution of the given non-linear first order differential equation. And when we solve equation for y, then express y in term of p and x, and then differentiate the equation with respect to x, and after differentiating actually y we take the derivative when the equation solvable for y. When we express y in term of p and x, then after differentiation with respect to x, we obtain dy by dp. So put dy by we obtain dy by dx. So put dy by dx as a p and find the value of p, and then putting the value of p in the required solution. When we express y in term of p, we can easily eliminate the p term and we can obtain the solution of the given differential equations. Now this is the end of this segment. Thank you. Allah Hafiz.